This is the fourth part of our section 6.1. Are congruent figures also similar? Notice, by definition, any two congruent figures, like these two, these are congruent by side, side, side. They also have congruent corresponding angles. Also, their corresponding sides are proportional in the ratio of 1 to 1. 5 to 5, 7 to 7, 6 to 6, all reduced to 1 to 1. Therefore, congruent figures are similar and their scale factor is 1 to 1. So you can write a similarity statement and you could write a congruent statement for both of these triangles. Here's a key concept. Corresponding lengths in similar polygons, that's what we're going to look at here. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. If you're not sure what that means, let's apply it to this one. In this diagram, we have two triangles that are similar. So here's triangle TPR. It's similar to triangle XPZ. So that means we know 6 things. We know which angles are congruent. We know which sides correspond. Find the length of the altitude for segment PS. So if these two triangles are similar, let's find the scale factor. This segment P to R has a length of 6. What does segment PR go with? It goes with segment PZ, 6 to 8. That reduces. 2 goes into both. 3 to 4. Here's what that new concept is referring to. If this ratio is 3 to 4, then this ratio of altitudes is 3 to 4. And you could also use medians here or perpendicular bisectors or whatever. So we're going to use our scale factor, 3 to 4. The ratio of the altitudes also matches that scale factor. So we'll call this lowercase x. 4 times 5 is 20, 3 times 5 is 15. That's how long that altitude is, P to S. We're going to do the same thing again. These two triangles are similar, so we know 6 things. Find the length of segment KM. These are medians now. So, since we know these 6 things, we can write a scale factor. This is 48, so this is twice as big. So if you wanted to do that way, you could. We could write this ratio. 48 to something is going to be your scale factor. We're going to compare that with these pieces over here, 48 to 40. What goes into both? 8 does. 8 goes into 48 6 times, and 8 goes into 40 5 times. So your scale factor is 6 to 5. 6 to 5, 6 to 5, 6 to 5, 6 to 5. So we're going to write a proportion. 6 to 5 equals this ratio of medians. We'll call this guy lowercase x again. Now, this is the bigger triangle, so you better have a bigger or longer median. So the way we have it set up, that will be the longer of the two. 5 times 7 is 35, 6 times 7, 42.